Hello everyone, welcome to the tutorial class of Python language quantitative trading series. We have learned about some of the basic concepts of model execution in the previous session, and today we will continue with the second important concept in model execution, the rollback mechanism when executing a strategy on a real-time bar, that is, real-time price model. First, we set the execution model to tick model here. Set it as tick model. And then write the rollback mechanism of the strategy based on the real-time bar model mechanism in the strategy code page. The strategy will reset the user-defined variables before each new execution iteration is executed, which we name it as rollback. Here we can write the test code. Before writing the test code, we set a short backtest time range here. We set it at 2021 July 7th here as the beginning time, and set 2021 July 7th 9 o'clock 5 minutes. Here we set it the begin time at 9 o'clock. We set a 5-minute period testing and set the kline period as 1 minute. That is, we use a 1-minute kline chart to display. That is, the whole backtest runs on the real-time bar by passing 5 kline bars only. Then we go back to the strategy editing page. If you want to save the backtest settings, we can click the Save Settings here directly on FMZ. Just click Save Backtest Setting directly in the strategy code. Some backtest configuration information is saved in the form of code. We can see this comment code start with backtest, which is the specific embodiment of the backtest configuration information. At this point, click Save button here. We can see the strategy was saved successfully. If we open the strategy next time, we can try it. We can see it was saved. The parameter settings will be saved on the strategy backtest page directly. We write a simple demonstration strategy. First, declare a variable n and then assign it an initial value of 0. In order to distinguish the rollback mechanism on real-time bars from historic bars, we assign a cumulative value to n on real-time bars only. So here we use an if conditional clause, and the built-in Python language variable bar set is history, which means that if the bar where the strategy is running currently is a historical bar, bar set history it will return true of Boolean value. We perform the accumulation operation by adding not in front of it, meaning that when it is not in the historic bar, then we perform the next operation. If it's not on the historical bar, we need to output the log information. Use the runtime log information. Use the runtime log function we have learned before and input the demonstration information. For example, if I want to do n plus 1 on it, then we output the value of n first before n plus 1, and also the value of the current bar index, that is, the index of the current bar. With such an output sentence, it will print the log when it was triggered. At this point, we'll assign a value to n, let it self-increment by 1. And then print another log after n plus 1 to output the value of n and the bar index of the current bar. Here we add color to it also. Here we add a color to it, that is double F, 00, 00, which means the red color. After outputting the information, we need to print out the value of n. Here we don't need to write it in the if sentence because we need to print the n value what in the historical bar on the real-time bar and have it drawn on the subchart and observe the changes of n values on both historical and real-time bar. Here we use the plot function, name it as n. Set it to tick model. Here. And start backtest. We can see the logs printed out. We log the logs in red, where the logs are output, and then we look at the line of n values here. On the subchart, n is always 0 during the historical bar. And only when the real-time bar starts running does the value of n start to accumulate gradually from 1, just because we have set the condition in the test code. N is 0. That is, when it is not in the historical bar, do operations of n value. Some may have questions. We have set the take model. So on the real-time bar, shouldn't the code execution be performed once for every press change? Indeed, code execution was performed for each press change, but why did the value of n on each bar only increase by 1? Because we declare a variable for n value in the rollback mechanism. Here. And here we look at the log outputted in the log area on the k-line with the k-line index of 299. We see that before n plus 1, that is, when the code execution reaches the real-time bar, not bar state is history is true, and then the code execution starts. It printed a line of log, that is, printed n before n plus 1. Here we see the log information. Before n plus 1, n is 0. Bar index is 299. After n plus 1, n is 1. Bar index is still 299. Each time the press changes, the trading logic will be re-executed. Then we can see that the bar index 299 re-executed the strategy logic again, but when the logic is printed before n plus 1, n is reset to 0. On the second time entering into the logic, after outputting this line of log, the printed n is reset to 0 again. When the market change occurred on the real-time bar next time, and the strategy logic was re-executed again, n was reset to 0 again. This is the rollback mechanism. That is, the variable we declared will roll back. When it was executed, the k-line jumps from 299 to 300. The value of n before n plus 1 is 1, and it is 2 after n plus 1. But after that, it still resets until a newer k-line appears. That is, after the k-line n301 appeared, and then the n value is fixed to 2. So that's what we see on the chart. When it is on the real-time bar, the n value will plus only 1 every time, and rolls back after each execution. In fact, the k-line is just increased by 1 every time. That's the rollback mechanism of the strategy demonstration. Simply put, any variable declared based on the real-time bar model rolls back the value of the variable each time, until this real-time bar becomes a historical bar completely, and the n value is determined for the last time. To summarize, there are 3 points. First, when the strategy starts executing on the real-time bar, the strategy code will execute once every time the market changes. Second, when the strategy is executed on the real-time bar, the variables are rolled back before each execution of the strategy code. Third, When it's executed on the real-time bar, the variable is updated at the close to fix the value, which is the value of n fixed in our example and determined as a specific updated value. The next time the period is re-executed, the value of n changes and plus 1. Due to the data rollback mechanism, all curves and drawing operations on the chart may cause redraws. Let's modify the current code to another demonstration. And the strategy code will redraw. Here we modify n to the ternary operator means that when the open is greater than close, that is, when it is the current k line is negative, then execute n plus 1. If it's not negative, n is assigned to n, then we click Backtest. We must set the time begin and time ended same as euro. Here 20. Set the beginning time and the ending time same as euro. Then we click Backtest. And here we can see that sometimes the value of n remains the same. Because we can only see the final state, not the real-time state when backtesting. It should be noted that in the charts, sometimes real-time bar drawing operation may cause redrawing due to the calculation. Not only in this example, but we usually encounter redrawing. For example, drawing a golden cross or dead cross on the chart, MACD, or some SMA strategies, Boolean strategies, etc. It may be a cross on the current situation, but it may not after the market changes. This is a typical phenomenon in redrawing. So if you have any questions in the specific study, you are welcome to leave comments in the comment section or log into the FMZ platform directly. Leave messages in our community forum or the library. We will answer your questions as quickly as possible. Thank you for watching, and don't forget to like, follow, and repost our videos.